Hello everyone, I'll be starting in about a minute. So just stand by. I'm going to start sharing my slides. Ready? Oops. Okay, it's 1:45 and it's time to get started. So my name is Adam Sandman and I'll be talking today about the DevOps dance. Shift left, shift right, get it right. So first of all, before we get into today's talk, a little bit about me. I've actually been working in the software industry from the age of 10. And I was originally a programmer. I've written various computer games as a child. And when I grew up, I realized I wanted to be in technology. And I love technology and innovation. And I'm right now the director of technology at Inflectra, which is a US company focusing on software development, testing, and DevOps. And this talk is based on a lot of the experiences we have, both as an individual and as a company. And today I'm actually presenting to you live from Potsdam, Germany, where I'm actually attending a physical conference, which has been pretty cool. So hopefully I can share some interesting insights. If you have any questions, please write them in the chat window, in the Q&A. I'll be happy to get to them. So first of all, we're talking about what is DevOps and what is continuous testing. And then when we start to get into the DevOps dance, we'll first look about shifting left, shifting right, and then the middle part, which I think we often forget about, which is how do we look at what testing we've done, what testing we need to do, and decide when is it acceptable to release some software, because you never will have enough time to test everything. And at some point, you've got to make a decision to go live. So first of all, how can you shift left by adding more tests into your pipelines, into your DevOps process? What kind of tests should you shift left with? And then we'll talk about shifting right, moving into production, things that we often forget when we go live. And we'll then put it all together into an integrated process. And then I've got some tools you can look at which may be useful as part of your journey. This talk does assume you are familiar with some of the concepts of DevOps, but I will be starting at the beginning to give some background for those who may not be as familiar. So first of all, what is continuous testing and what is DevOps? So DevOps is really the fusion of development activities, software engineering. When we say it's development, it's not just the coding, it's also all of the designing and the specifications, the requirements, everything that goes into specifying and developing and building software. It involves all the quality and compliance and testing and process to make sure that it works. But really importantly, it's the operation side. Things that traditionally, when you were looking at agile teams and building software quickly, the infrastructure was never fast enough. You could write code quickly, you could test it faster, but the infrastructure couldn't keep up. So DevOps is basically fusing all of that together into what we call the DevOps cycle, or the infinity loop. And the DevOps cycle takes an idea, a new feature, or an enhancement to an existing feature or some idea, and turning that into something working that's released, that's out there being used, and then is being supported, and we then use that information as feedback. So planning, creating, verify, building it, packaging it up, releasing it, configuring it, and it goes live, and we can check it's still working, which we call monitoring. And as we monitor things, we obviously get improvements that become new ideas. That's why it's an infinity loop. Now, the question that people want to know is, where is the testing? If you go back into that diagram, you might look at it and say, where is the testing? That's a good question. Because, for example, you could say the testing is in the verification, verify. That's where the testing is. Maybe the testing is in the planning. We should plan for testing. But the answer really, it's more complicated than that. Continuous testing is actually the process of taking tests and putting them into that infinity loop, into what we call the pipeline, and basically using those tests to get feedback to help us improve our activities later on in the cycle, and then doing different kinds of tests later on in the cycle. And then once we've released it, It's also going to include testing once we've gone live into production and getting feedback, which is also a form of testing, and putting that back into the beginning. So basically, if you look at continuous testing, its name says it's not just testing at any one point. It's testing throughout, from validating the requirements at the beginning and the user stories, to the system requirements, to the building and the testing of the initial features, testing as you integrate it, testing as you package it, testing once it's released into production, and monitoring it once it's in production, which is a form of testing anyway. So really, if you think about testing, continuous testing is everywhere. So the fact that testing is everywhere doesn't mean you should be doing the same kinds of tests. The testing you'll do at the beginning, when you're planning and creating, will not be the same as the testing you'll be doing later on when you're in monitoring release. So, first of all, before we get into that though, there are some key facts and myths about continuous testing in DevOps. So the first thing is, with DevOps in general, DevOps by itself has a tendency to result in people doing things faster. And the problem is, when you do things faster, it doesn't necessarily mean you're doing things better. And what will often happen is you're pushing low quality code into production faster, and that's bad. And because you're doing things faster, you may not have time to have visibility. You push the button, the code is committed, it's pushed into the repository, it gets deployed into a staging environment, automated tests run, it gets deployed into production. The problem with that is there's no human visibility, no feedback. And so therefore you're not really assessing and addressing any risk. So that's actually bad. So what we find is if you just do DevOps and you don't think about the testing and continuous testing, you don't get any benefits. You actually just get chaos and the business value drops. The other thing we found is when people talk about continuous testing, they think a lot about automated testing in the DevOps pipeline earlier on, like do more testing sooner, shift lefting. We'll talk more about that. But that's not the truth. Continuous testing is not just about automation. It's not just doing it earlier. It's about all of the things that need to happen throughout the whole cycle. So continuous testing, as its name specifies in DevOps, it's about testing everything at all times. So some best practices though. First of all, continuous does mean your testing is happening before you make a software change, during and after. So before you make any code changes, you're testing before you build something. You're testing the design, testing the requirements, you're doing test-driven development. Once you do the development, you're doing automated testing, of course. Once you've gone live, you're still testing. Another thing is collab requirements. Requirements should not be something that the developers go off and figure out themselves. It shouldn't be the product owner. It should not just be the testers. Everyone should be collaborating. Testers are usually the voice of the user. They understand what the system has to do. When you test something, you figure out not just does it work, but is it delivering the value? Is it delivering the customer experience? Therefore, you need to validate that before you build anything. So we would recommend pair up your developers and your testers together, review the test cases, review the system, make sure you're putting them together. You should be doing automated testing and deploying it into your pipeline as soon as possible. Another really good important thing is don't assume that your process today is the best. Look at what you're doing each day and then look at how can you improve your approach. Maybe there's some tests you can get rid of because they're slowing everything down and they don't deliver value. They pass every time. Maybe we can simplify. Also look at customer feedback and business metrics. Just because the system works doesn't mean the system's actually delivering any value. Maybe its usability is terrible. Maybe it's slow. Maybe customers really find it hard to use. It's not intuitive. So these are some of the things that you need to incorporate into your pipeline. Take that customer feedback and incorporate that into the system. After all, quality is not just tested. It also means it delivers fitness for purpose. Is the system appropriate? Is it delivering value? So that's a little bit about DevOps and about continuous testing. So the DevOps dance is how I think of it. It's like the dance. You shift to the left and you shift to the right. And so when we first think about that, let's talk about shifting left. So shifting left is all about left in the cycle. What that means is, whereas we might have built the software about doing things earlier. So how do we do that? Well, first of all, what you should do is look at the key parts of the system and identify what kinds of tests can we do early. Depending on the system you're building, you may not be able to do everything early. That's okay. Look at things you can do early and identify problems early, identify risks early. It doesn't mean you're going to fix them all right now. It might just mean you run some tests, do some checks, figure out where is the biggest risk in this version. What have we changed that's going to cause the most problems? Once we know that's the case, we can then spend more time later doing a deeper analysis. And it's important to look at different aspects of the system. Not just does it work, but is it performant? Does it fast enough? Is it secure? The system might work, but can we integrate it into all the other systems we have to integrate it? Do we have the right infrastructure for going live? What's the usability like? We should identify all these things up front, and we need to spend some time on these earlier in the life cycle. Don't wait till you've built the system before checking is it usable. If the system is not usable, it will be very, very hard to change it later, typically. Same thing with performance. You're not going to necessarily want to spend all your time doing performance testing, but you at least should do some basic analysis to understand how performant is it. Are we miles away or are we close? Okay. And the last thing is early exploration of features to understand any business issues or risks is useful too. So just looking at the system before it's finished and having people understand how is it going to work, does it meet the business needs. Some best practices would be in the shift left approach, make sure you are doing continuous integration. You could be using things like Jenkins, GitLab, GitHub, TeamCity. There's plenty of tools that do continuous integration. Once you do have a CI in place, whatever tools you're using, make sure you've got a decent set of automated tests that can run. You should be doing at least unit testing, which is reliable, easy to maintain. API testing is really important because if you're developing APIs, other tools will depend on it. And if you break your APIs, you'll break all the other tools that use it. And if you can, have some automated user interface tests, UI tests. Don't make that the focus. Everyone wants to focus on those. Those are actually the hardest to build and the most difficult to maintain. So do unit tests, API tests, and first, and then with time left, do some automated tests, some unit tests. So unit testing, there's plenty of tools and frameworks out there. Here's some examples. Depending on the language you're using, there are different unit tests you may choose. If you're writing in Python, you'll probably use PyTest. If you're writing in JavaScript, you'll probably use Mocha. Whatever it is you're using, there are open source unit tests available. These technologies really make it easy to do comprehensive unit testing of all the code so you have good coverage. And then you can tie it back into a test management tool for reporting and analytics. With API and integration testing, make sure you understand what APIs your system is exposing. Also realize that once you create an API and release it, it's going to take on a life of its own. People are going to start using it even when you don't know. So you might release an API and people start using it, and then you realize that, wow, I wish I'd changed the API, and then you'll break the API and other systems that depend on you will fail. So you have to be very, very mindful. If you're going to have different APIs and make changes, you should ideally version them. And I have a whole other talk on APIs and API testing. But just needless to say, API testing is really important because it is the contract your system has with other tools. And if you make a change that breaks it, or it just breaks in general, a lot of other systems will not work, and your product will not be perceived as being of high quality. Once you've done the unit testing, integrated chair testing, and API testing, now you could look at UI testing. And for UI testing, it is the most expensive testing to do because it's the most complicated. The user interface changes the most frequently. So be careful. Try and automate what you can and use manual testing and human testing for what you can't. It's okay not to automate everything. What we would always say, take a business approach. Look at how many hours will it take to automate the test, how many hours will it save. If you've got one test that takes hours and hours and hours to run manually, and you run with lots of different combinations, logging in with every browser, the computers do that really well. That's a great candidate for automation. If, on the other hand, it's a really complex scenario, you're only going to run it once or twice each release, maybe manual testing for that moment is better. So you'll understand, but make sure you do have a strategy in the early phases for testing. The other thing is, a most important thing that people forget to do is non-functional testing. Early in the pipeline, we're still building the software. We're in this early environment. We haven't got the finished product yet. We're not running on the production hardware yet. People assume, therefore, that we can't do performance testing, security testing, usability, or compatibility testing. Wrong. You can do some of these things. Now, that doesn't mean you're going to test it to 100th level, you're not going to spend as much time doing it now. You'll do more later. But it's good to at least do enough of the testing of these types so you can find out if there's a problem for later. And the other thing I would recommend is when it comes to the manual side of testing, exploratory testing is a good option early in these days. You haven't really had time yet to write test cases. You don't have the descriptive steps. That's okay. Good testers that are experienced, you can give them a system and the high-level business requirements or the user stories, and they can look at those and determine where do they think the problems are, where the risks are. They can start to look at them and find out. Especially in the early phases when the functionality is still evolving, good exploratory testers don't need to have a lot of instructions. They can look at the system that's half built, and with a bit of guidance, as long as they know what's supposed to work and what's not supposed to work, they can find things that you won't know about, and so you'll have time to fix them later in the cycle. In addition, some tools you can use in your pipeline, what we would recommend. First of all, dependency checkers are tools that can help make sure you're not missing any code libraries. Static code analysis tools will find if there's any bad code you're putting in. It will look for things like any libraries that are out of date, or any code you've written the code looks like it's badly written. It's not very performant. You'll then have the unit test frameworks to do all the automated testing at the unit test level. There's some examples here. You can do things around performance testing. Again, things like JMeter and Gatling are very good in the early stages because they're quite simple to set up and they're open source tools. Do your API testing. There's some tools here for that. And also security testing. Again, don't wait to the last minute. Tools like Burp Suite and OWASP are really good. You can do some basic vulnerability testing and some pen testing just to see how the application looks. If you've got major issues, major vulnerabilities, you will need more time to fix them. And so it's good to at least know early, how close are you? And then with UI testing, if you can do automation, there are some commercial tools, there are open source tools, do some UI testing, but just know that if the screens are changing frequently, it may not be worth automating every screen. Okay, so we've shifted left. We put all these new high-tech tests into the pipeline. As we now finish the development and the creation stage, we're moving into the verification. We've got a good set of tests. We understand where the risks are. Now, the other part of the equation is shifting right. So shifting right is the other time when people tend to forget about the importance of testing in DevOps. Because once you release the software, it's like, yay, software is released. Woohoo, we're excited. We can go home, have a drink. Life is good. And if you've ever seen any of those videos of software that's gone bad, when people have released software, there's always the picture of the celebration. And meanwhile, the whole system is collapsing. So you don't want to be that person on Twitter. So shifting right is when you've gone live with the system, it's being able to understand how does the system behave in production. So first of all, and that could be because you want to fix something, or it could just be because you want to understand how to mitigate something without fixing it. Maybe other things you can do. So first of all, there are some types of testing you can do in production, and although we're not test in production, you really are testing. We call it feedback or monitoring, but it's a bit like testing. So the first thing you could do is, if you're not sure, you can release the software to a smaller group. So instead of releasing the new version to every single region at once, you could decide that we're going to release the new version just to one region. That's called canary testing. We have the canary in the coal mine. They're the ones who are going to find any issues. If you've got users that are particularly experienced or tend to find things easily early, maybe you release it just to those people. Have an opt-in channel. Like if you use a lot of the browsers, like Chrome and Firefox, they have the stable channel and they have the experimental channel, and you can opt into a different update cycle and be one of the early testers. So you could do the same thing with your users. Have an opt-in channel. If not, you could, and you're not unknown, and that's not something you can do, you could also do what's called A/B testing. You could release the old version to half your customers and the new version to half your customers, and you can monitor things. You can monitor lots of interesting things, not just does the system work better, but are more business transactions happening? If it's a shopping site, are people buying more products, bigger products? Whatever the metrics are for success. The other thing you can do once you've gone live and are live is do continue to do usability testing. You should do usability testing before you develop the software, of course. But once you've gone live, monitoring actual users using it is really important. You can have settings. You can do it virtually. Lots of tools to make that happen. But make sure you're monitoring the user experience. Another thing would be business satisfaction. Send out surveys to your users. Are you noticing people like the software more than they used to? Maybe they like it less. and monitor business metrics to see what's the underlying value of the changes. Some things you can do, you should be doing, of course, in the shift right would be, if you can, you've got the software, it's developed, it's tested, it's all good to go, continuous deployment. Try and automate the deployment process from release to live as much as possible. Whether it's a traditional application that people install themselves, if it's a SaaS product that you update for them, or it's a container that you release, or it's a virtual machine, whatever the process for giving the software to the end users, that's a process that needs to be tested. And oftentimes we don't test it. We build the software, we test it, and then we deploy it using some manual methods or some non-repeatable methods. Automating the process from release to being in production is important, and make sure you have ways of testing that. And ideally, automate those tests. Automate as much as you can. It's amazing how many times problems will be in the deployment process, not in the software itself. Another really important thing would be the business side. So when you release a new version of the software, you can measure things like the system uptime. You can measure things like the performance of people getting transactions to the system. You can measure the screen load times. There's lots of different performance and business metrics you can track once you've gone live. But one thing would be business metrics, which are the actual metrics the business is using. So, for example, it was a shopping site. It could be number of orders, as I said. It could be the number of products in the cart. It could be the speed at which people can complete the checkout process. It could be the size of the orders. Maybe this whole new feature is to allow people to buy more items. Maybe it's got comparison shopping. Whatever it is, there are obviously metrics that you as the business care about. If you start to see these change in unexpected ways, it can be a sign of problem. If, for example, people traditionally put 3 items in their shopping cart and buy, and your monitoring system detects that suddenly after the new version, people are only putting 1 item in the shopping cart. Now, if it happens once, it might be a fluke. But if you start to see a trend where over days and days and days, the number of items in the shopping cart is much lower than it used to be, it could signify there's actually a problem with the shopping cart where it doesn't make it easy to add a second item. So use business metrics from the actual live system to help find problems. And don't forget your users and your support agents. When you release software, there's usually someone, or hopefully someone supporting it, getting feedback, answering questions, dealing with training issues. Whatever your support system is, if it's Zendesk or Chronodesk or ServiceNow, whatever tools you're using for capturing support issues, make sure those are integrated into your pipeline, meaning that if users have lots of feedback, they may have identified a bug early. If everyone's logging a bug about something and it's all around the same time, it's usually an indication that something has slipped through and that you have a problem. Or it could just be they have good ideas of feedback for how to make the system better. So whether it's bugs, enhancements, or other ideas, your users are a great source of ideas and feedback, and your pipeline, your process should actively encourage that and have a process for turning these questions and issues into new items for your backlog. So some tools you could look at for the monitoring side, there's tools like Dynatrace, which are commercial, SolarWinds, that's less popular these days because of the reasons we all know about. There's also things like CloudWatch, which is part of the Amazon Web Service Suite. Google and Microsoft have similar tools. So if you are using a cloud platform, there are some monitoring tools built into that. Obviously, for getting customer data back from users, tools like Zendesk, Chronodesk, Remedy, ServiceNow, Freshdesk, whatever you're using to manage your help desk, find a way to have those send information back into your DevOps tools, into your requirements process. Whatever the process where you identify new features for your backlog, make sure your help desk is integrated into that. Another area people forget about is customer behavior. Particularly if it's a web-based application and it's internet hosted, there's tools which, like from Google Analytics, which is a free part of the Google Webmaster Suite, which are incredible. I mean, Google will let you see your users moving through the application. You can see how many users clicked on this link, how many users clicked on that link. Did they get stuck on this page? So using the Google Analytics tool set is a really powerful way of seeing what your users are doing, and you can see the flow through the application. And it'll help you find if there are usability issues, or maybe there's something wrong with some of the pages. People are navigating around a broken page. You'll see it literally graphically in Google Analytics. So it's a very useful tool. It's not a traditional testing tool, but it's a really good production monitoring tool. Splunk and Matimo and some other tools you can use as well. In addition to the sort of system side of monitoring, there's also business monitoring. You can use things like Power BI, other tools that hook into your existing data sets from your order management, from your shopping cart, whatever the business is doing. Get some tools to be able to take the business data and combine it with the system data. Okay, we released a new version on this day, and on the same day, sales increased. We changed the system again, it went down. So if you start to see correlations between business data and system activities, you'll start to see how is your development and process, how is your pipeline, how is your DevOps process actually affecting the business. And there's some tools like Tableau for visualization, and there's some analytics tools like Quillic and Talius that you can use as well. And then don't forget your customers. Just use tools like Delighted or Ask Nicely. You can use those to get your customer feedback scores, net promoter scores. Okay, and the last part is the middle. So we've shifted left. We've added some tests into our pipeline. We've identified the areas of risk. We know that when we go live, we have some tools that can monitor what's going on. What about the middle part, traditionally the testing part? So what do we do there? Because we've started testing earlier. We've done a lot of automation tests earlier. We've done some performance and security tests, things we normally wouldn't have done until later, and we know we're going to monitor later. So in the middle part, when we're actually doing what we would normally have done as testing, what do we do that's different? Well, the big thing here is we're assessing the risk, and unless we're completely automated with an AI engine, for the most part, someone has to decide, are we going to go live? Now, unfortunately, as the cartoon here shows from Dilbert, there's never enough time for testing. 2 weeks, 3 weeks, a month. Whenever you have that much time, it doesn't matter. You'll always need more time, just the way it is. The question is, what do we do with that time? So the questions we would say are, first of all, okay, based on where the system is today and where it will be at the end of this period of time, can we go release into production? And really, what do we need to know if we can go into production? So how do we know if we've tested the right areas? Maybe we spent 2 weeks of testing, but we've tested the wrong areas or areas that weren't important enough, and now we're short of time. Now we don't know. So we never have enough time to test everything. So the key will be using a risk-based approach to know where to test. Because ultimately, testing is about managing technical risk. You never fix everything. You never test everything. There's never enough time. The question is really, testing is a way of identifying risk in the system, because you test and you find something, or you don't find something. Either way, it tells you something. It tells you information, and that lets managers and the person in charge or the product owner decide, is the risk sufficiently mitigated that I'm comfortable going live? So how would you go about that? Well, there's different techniques. And you can look at risk-based testing. It's a whole methodology. It's a whole presentation that's separate from this. But from a shift left to shift right approach, what you would typically want to do, I think, is if you've looked at some of these different types of tests earlier in the pipeline. So we did some unit testing, we did some API testing, we did some security testing, we did some limited performance testing, we did some limited exploratory testing earlier on. That was shift left. When we did that, we found out that the unit tests were a bit dodgy, a bit ropey. Some of the tests passed, some of the tests failed. It was not as well tested as we thought. The API tests went 100% fine, no problem. Security tests, no major issues, some small things we can address. Performance testing, was really slow. We're worried about that. Exploratory testing found some major issues. So if you put those together, what you'll do in the middle part is take the areas that we identified the most risk, the 3 in yellow in this case, and we'll spend more time doing those. And the areas that are in green that we didn't find any issues, we will spend either less or no time, maybe, on those areas. So it lets us know, based on what we found earlier, there's a higher degree of risk in those areas later. So focus your limited time on the areas with the most risk. Now, what does that mean? How is that different from what we did earlier? Well, here's an example using performance testing. You can see here we've got performance testing on the left and performance testing on the right. What's different? Well, on the left, we're in development. We're in our CI environment. We've got development machines. We've got maybe it's a cloud-based CI pipeline. Maybe it's an on-premise pipeline. Whatever it is, it's not full-scale production environment. So we're going to do some testing. We're going to use some load testing tools. It's a development environment. It's on the main network. So there's no, it's not separated out from the rest of the internet or the rest of our network. So there could be some effects of that. We're only going to put through a small number of users, maybe 10 virtual users, 10,000 requests. and we're going to look at what happened. And if we find that it seems reasonably fast, or it's certainly as fast as it used to be, then maybe we're okay. The key is sometimes not what the actual number is, but does it vary? If we do this every single CI build and we record the time it takes to run these tests, we can look at a trend analysis and see every time we do a CI build, all of our performance tests take about 10 seconds. We now made a new change to the system, it takes 20 seconds. Now, that doesn't mean that that is necessarily a problem, because maybe it's still fast, maybe it's going to be fast enough, but we know that there's definitely an area of risk. So when we go to do full-blown load testing, we're going to get a production environment and copy it. We're going to dedicate the environment. We'll isolate the network so there's no external factors. And we're going to send 10,000 virtual users at it, multiple different regions, using cloud generators, load coming from Europe, from North America, everywhere. And we'll test it for 4 hours. We'll figure out how much can it take, when does it break. We'll do a full load test. And then we'll look at do we meet our SLAs? Is it fast enough for the system we've released, what we're supposed to make? So that's the difference. The first set of tests we were doing was not to say, is it fast enough? It was just to say, is the performance likely to be an issue in this release or not? And if yes, we'll do more load testing. And then in that load testing, we will say, did we meet our SLAs? Same thing if you looked at security testing or any other type of testing, functionality testing even. The early testing is just to find out, are we 99% there? Are we 10% there? What's the gap? And then later on, we'll spend more time on it. The other thing I would say is, when you're looking at when to do the testing and where to do it, make sure you look at the environments you have and when you're doing it. So when you're first doing testing, you're working in the shift left, you've got code in the pipeline, it's building every single hour as you commit any feature. You may only work in a couple of environments, so you might choose what we call happy path. That's where, using the system as it was intended, we're using it on a fast network, on a fast modern browser that we support, like Chrome. And then we'll move, as we have more time as we get later on, once we know the system actually does work in the happy path, once we know that the preferred environment does work, say it's Chrome running on Windows, then we are confident that we should then spend some more time trying more complex user cases, more difficult paths through the application. We also might want to try different environments. Maybe we try Firefox, Safari. Maybe we have to support IE11 still. I don't know. But whatever it is you have to test, you're going to slowly make the conditions more difficult over time. But there's no point, as you start right at the beginning, when you first build the software in the early phases, there's no point doing hard scenarios on IE11, because if it breaks, you won't know where the problem is. Was the problem the browser compatibility? Was the problem in the system? The first thing to do is, does it work in the best case, and then slowly look for more difficult situations. So really important to do that. Don't try and do everything at once. Know what you're testing, when you're testing, and at which point in that cycle. And so when at some point you get to the question we all care about, which is, shall we ship the software? And so we've done all this automated testing. We've done it in the shift left. We've done all our functional testing, load testing, etc. We've now got to the main set of tests. We've automated as much as we can. Everything's looking green. We're in good shape. The question is, should we ship the software? It's not an obvious answer, actually. Why is that? Everything passes, should be obvious. Go live. Well, typically that's not the case. Typically, this is what we're thinking of. This is the box of our system. The system is basically user stories, requirements, specifications, regulations, all those things. And we've built some tests around that. We understand how it's meant to work. We understand how to test it. We've tested it. It all comes to work. We're great. But the real system doesn't look like this box. The real system looks like this. It's not straight. It's not simple. Humans have built it. We've written the requirements. There's flaws in it. It's not as simple as our nice perfect box. And so when you actually look at the real system being used by real users in real environments, maybe they're running to catch the train and they're using the app on their phone and the signal drops halfway through. That's the real way of using a system. We may have designed it to be used at a desk with an internet that doesn't change. No, that's not necessarily how it's going to be used. So the actual system being used by actual people in their actual day-to-day environments, that's the reality. So once you've defined the system, tested it in the perfect sense, and this is the actual system, what we have here then what we call the edge cases, like the edges. And these are the cases where we're trying the system in extreme. So we'll use it on a small device and a low network, and the internet connectivity is perhaps sporadic. Does it still work? So it's really important to not only have all your automated tests pass, but have someone, a person usually, pretend to be your users and use the system like your users will. And your users are not following test scripts. They're not going step 1, do this, step 2, doing that. When a user uses your app, they're probably getting the app and going, oh, how does this work? Click, 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 click. They're moving around. They're doing 3 things at once. They're changing tabs. That's the real system being used by real people. Make sure you have time for people to do that. Have your testers, have your people who are doing your quality actually spend some time like a real user. Exploratory testing, just half an hour. My objective is to try and test the shopping system, and they're just going to do it and see what they find. I guarantee you they will find things that you haven't seen in your automated scripts. They will find things that you've missed. And so therefore, ultimately, the decide to release is not going to be technical. The decision to release is a business decision. Because when you go live with a new version of anything or a new product in general, there's the risk of releasing, the risk that we've missed something, the risk that something's going to make it worse. But if you don't release, then people are using the old version, and I'm sure the old version has issues too. And so when you release the version with new features and improvements and bug fixes, security fixes, you're fixing some things, but you may be making things worse. You have to decide, when is the quality good enough? When are you ready? It's never going to be perfect. So it's a business decision. So and a lot of times there's a lot of emotion. Testers are like, it's not working. Developers will be like, yes, it's great. Let's do it. The person in charge has to make a business decision to say, I'm willing to accept the risk of doing or not doing. So that's the important thing. So just to wrap up, before we move into Q&A, make sure you integrate the automated techniques and other shift left techniques into your software development pipeline. Understand where the most risk is in your project. Take those risk areas and then use those to focus the additional efforts afterwards. And then once you've gone live, or as you go live, add techniques into monitoring, into post-production, post-deployment, so that you can actually verify what happened after you've gone live. Is the software working still? Is your business value being created? Have you made things worse? And you can roll back, you can change things, but make sure there's monitoring in place so that when you release something, it's not the end of the story. And then lastly, when you're deciding whether to go live or not, understand that it's not going to be a black and white technical decision. It's a business decision, and there's risk involved whether you do something or don't do something. So make sure that that's well understood. And with that, it's time for questions. Just checking here for questions. Okay, thank you very much. Thanks for attending. Hope you enjoyed it. Have a great rest of the day and enjoy the rest of the conference. And thanks for the organizers.